everyone. You are welcome to the second session under Unit 1. In this session, we are going to look at liquid-liquid separation. Okay, so at the end of the session, you should be able to separate a two-component mixture into the individual components by solvent extraction. You should be able to identify the separated compounds and their purity by melting point determination. Okay, so in your experiment, the mixture to be separated contains equal parts of these two compounds, benzoic acid and then triphenylcarbinol, right? So during the experiment, you are supposed to add about 4 grams of the mixture into a separatory funnel, and then you add about 40 ml of ether to it. Then you add 10 ml of 10% sodium bicarbonate solution to the contents in your separatory funnel, and then you cock it and then you shake it, right? While periodically venting the separatory funnel to allow the build-up pressure to be released. Now, when you add a solution of sodium bicarbonate with your organic solvent, which is in this case the ether, what happens is you are going to have two layers being formed. So your benzoic acid will be in the aqueous layer, whereas your triphenylcarbinol will be in the organic layer. So the ether will be at the top, whilst the aqueous layer will be at the bottom. So next is to do the extraction one more time. So after draining off your ether layer and then having your aqueous layer, you wash it again with 30 ml portions of the sodium bicarbonate. So you wash the ether layer one more time. So about 1 or 2 more times, just to be sure that you've had a greater amount of your organic component coming into the ether layer. We're leaving the ether layer and then having most of your benzoic acid going into the aqueous layer. Now, after draining off your aqueous layer and then your organic layer, you can treat the organic layer with anhydrous sodium sulfate, which is a drying agent, purposely to remove other trace of water that was still in the organic layer. And then you go ahead and then you concentrate by heating your separate samples on a steam bath. Okay, so after concentrating your aqueous layer to a certain volume, you can continue by filtering the solution using gravity filtration and a filter paper, and then gravity filtration. Afterwards, you acidify the solution with some dilute hydrochloric acid, and the solid that precipitates on the filter paper can be weighed, and then you can use that to calculate your percentage yield of the benzoic acid. Now, with the ether layer, you are going to have to filter the solution into a second flask, and after rinsing, sometimes it's better to use some amount of ether to rinse the content of the layer to make sure that all the ether solution is being filtered off into a different container. Afterwards, you can continue by simple distillation, using the simple distillation setup to get most of the content out to get your organic layer. Now, after getting the organic layer, then you can concentrate that layer as well, and then allow the content to dry. After concentrating it to a certain volume, you can filter it using gravity filtration, and then you determine the melting point of the content you have now. So now you determine the melting point first of the original mixture and then of each of the products you've extracted, and then you compare your results as well. Now, of course, you are going to weigh every product you get from the liquid extraction or the solvent extraction method. Every product you get, you are going to weigh them, and then you determine their melting points, and then you compare that melting point value with the known compounds as to whether you were able to successfully extract the organic compound from the mixture. So afterwards, you during in your report writing, you need to be able to draw a flow chart to describe how you were able to isolate the components in the mixture. You should be able to calculate your percentage recovery as well. You should be able to compare the melting point of your sample to the melting point of the mixture. So you have to be able to know the standard um, compounds melting point, and then you compare the melting point of your extract as well. So one thing you have to know is if the melting point of the extract or the component you are able to obtain from the experiment is too high or too low from literature values, then it means your extract is slightly impure, right? So you have to take note of that. Then, of course, the last thing you would want to talk about is um, how could the separation and then the recovery of your compound separated be improved. So, whilst you were extracting your compounds, is there any other way you feel like any other process that you feel like it needs optimization just to increase um, um, the efficiency of that extraction process? Is there any other thing you feel like you can add or do that will improve the separation or the recovery of the component?